And welcome everybody to the Daily Space Weather Show. Exciting times continue for space weather as geomagnetic storm conditions continue for days, and you can expect them to continue throughout the night tonight, well into tomorrow morning. And then guess what? Tomorrow night, more space weather likely coming through. So exciting stuff coming at you from the Smash News Network, least busted name in news. We're looking at the past 24 hours here from SDO. And today's featured wavelengths are 131 plus 171 angstroms. It's great at showing the filamentary features associated with magnetic fields, the fields to which the plasma orients itself. And no major flares over the past 24 hours. In fact, a general dip in solar activity. Hopefully some of you have come out of your bunkers long enough to watch this video. So here's the equatorial zoom. We do have some activity there setting on the eastern limb, and also some active sunspots moving into the Earth-facing strike zone. We'll also show the southern polar region before we continue on. And by the way, these videos are brought to you in part by the Smash Team at smashomash.com/Smash Team. We launched our subscription services site officially back in October of 2021. If you want additional content and you want to support the channel, become a member of the Smash Team. If you want email alerts, you can join the Smash Team as well. Even the bronze level Smash Team gets email alerts about videos just like this one. So smashomash.com/Smash Team is our homemade paywall. So we built our own subscription services to replace Patreon. We are still on Patreon. You can find all kinds of links there and so on. These videos are brought to you in part by the Smash Team at smashomash.com/Smash Team, especially the gold and silver Smash Team level members. So thanks to them especially. smashomash.com/Smash Team. Also, thanks to our new Twitter followers. Congratulations on realizing the Twitter account exists. If you're doing social media, we recommend Twitter. Although it is pretty pathetic. It's I don't know, it's where we do most of our interactions. So join us over on there. It's a great place to share things like images of the aurora, which we've been doing regularly. Also, follow the hashtag #NameThatFilament over there on Twitter to name filaments after living people. So x.com/smashomash. You'll find us all over the internet as that. Also visit our links. You'll find paid affiliate links below this video in the description, like the Hemp Lucid shop. Also the Amazon shop. You can pick up the same coffee that we drink in the morning, the Cameron's Organic Whole Bean Scandinavian Blend. Save big on your coffee. That's a 4-pound bag, by the way. It's $23.38 for 4 pounds. So not as expensive as it might seem. Today's featured product is, and at the merch shop you can save 20 to 60% site-wide. The featured product is, do not pole vault the caldera, because if you're going through hell, keep going. Our finest days lie ahead, folks. So if you're going on a volcanic vacation, leave the vault pole at home. Don't become part of the lithosphere. We need the views on YouTube. Seriously though, the shirt has the YouTube URL right there at the top, and our homepage down at the bottom. This public service message brought to you at massive personal risk and expense by Smash staff, and I give her a raise by picking up our most popular piece of merch, the Do Not Pole Vault the Caldera. And you can find all of those links on the homepage. There's the Smash-O merch link. You'll also find this Redbubble link, and there's another one down here. Yeah, so plenty of places to click on things on the homepage. And welcome to the Neo-Renaissance. Congratulations on realizing that the channel and the homepage, and that everything associated with the content exists. Smashomash.com. And next we're looking at the yesterday plus today imagery here. That's SDO continuum for November 5th and November 6th to date. So as forecast yesterday, we have seen a general decline in solar activity here. We've seen some sunspots evaporating, some setting in the west, and no new ones to replace them. So most of the visible sunspots here have remained largely stable for the past 24 hours. And there is the colorized magnetogram for November 5th and November 6th to date. So let's take a brief look at volcanoes, and it's only showing one on the list here. I don't know what's up with that. Only one volcano there appearing on volcanodiscovery.com. And for some reason, it's only showing one erupting volcano. It's Mount Ibu on the Isle of Halmahera, Indonesia, which is producing a volcanic ash plume of 7,000 feet altitude. As it explodes, it's a flight level 070. I guess it's a volcanic downtick on a global scale. Next, looking at seismicity. Here are the past 24 hours after we show the past 90 days. So there's the 90-day graph. And there is a little bit of a 7 magnitude earthquake drought here. We are a little bit overdue for a 7 magnitude earthquake. I believe even for a larger event, but I'll just leave it there. We'll cite the quakes of a 5 or greater magnitude for the past 24 hours. Here you go. And the first one on the list was in the southern Indian Ocean. That was at 5:44 Universal Time this morning, that 5.1. At about 5:45 Universal Time. Then Nepal had a 5.3. That was about 5 hours later there at 10:46. And then at 12:04 Universal Time, the Mid-Atlantic Ridge saw a 5.5. Chile had a 5.2. The largest quake in the Western world. Timor-Leste had a 5.2. That was at 15:36 Universal Time this afternoon. And last but not least, Solomon Islands had a 5.3 at 21:30 Universal Time, just about a half an hour before this broadcast was recorded. Next, getting back to some space facts. The 10.7 centimeter radio flux has declined back down to 146 solar flux units. So there's the radio flux over the past year, represented by the black line. The red line below it is the sunspot number. Radio flux now 146. That needs to be updated. So, like we said, we are expecting geomagnetic storm conditions to remain throughout the night and throughout the day tomorrow into the 7th. So, we might see some more significant geomagnetic storm activities. The highest we saw was a KP7. We'll cover that here in a moment. And most of our content is now back. So some of the applets that we used to show all the time were out for a few days, and now they are back. So again, more CME activity likely to strike Earth, followed by a coronal hole high-speed stream. So there's not going to be a big lull in the action. Geomagnetic storm and unrest conditions to continue here for another couple of days at least. Here's Earth's magnetic moment from space for the past 4 hours. That's our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure. Again, that is the last 4 hours of Earth's magnetic moment from space, and the likelihood of seeing aurorae at mid-latitudes is going to be there throughout the night. So make sure you stay tuned for our meteorology segment where we show you the likelihood of seeing cloudy conditions or clear conditions at your location. Next, our ground magnetic perturbations map. Here are the changes to Earth's B field around North America. So that's the past 4 hours of the local region. We'll also show the full globe view. So there's the globe view. And lots of folks have been seeing the aurora. So if you think there's a chance you might be able to catch it, and we're going to show you some more tips on how to do so here in a moment, make sure you take video and photographs of it, as most of the aurora is ultraviolet light, which is not visible to the naked eye. So here are the auroral forecasts there. That's the 30-minute forecast. So that's one way to guess where you might be able to see the aurora from. And we're going to show a special feature here for our North American viewers. There you can see some variations in the solar wind there, creating some variations in the aurora likely. And here's our geoelectric field map. This shows actual induction into the power grid. And so that's a great map. If you are expecting the possibility of aurora and you see your location light up on the map, there's a distinct possibility you might be able to see the aurora where you're located. So that's empirical data. It's literally showing voltage in the power grid for the US and Canada. Keep in mind, folks, the aurora can show up very rapidly and disappear just as rapidly. So you have to, timing is everything when it comes to taking photos and video of the aurora borealis. So again, the highest KP we saw was KP7, a G3 level geomagnetic storm. I think that was about what we forecasted when we were telling you about the CMEs when they first launched. So yeah, KP7 was as high as it got. And we're not expecting it to get any higher than that, by the way. We think the strongest part of the geomagnetic storm has already shown up. Current conditions are a G1 class geomagnetic storm at KP 5.33. So here's the real-time solar wind data. There's the ACE. The ACE showing quite an elevated solar wind speed here, over 700 kilometers per second, having made it all the way up to over 800 kilometers per second. Check it out. So over 800 kilometers per second, that's the highest it's been for quite some time. The Discover spacecraft, also at Lagrangian point 1, showing much slower solar winds there, having only reached above 600. Current conditions at Discover are less than 500 kilometers per second for the solar wind velocity. Solar wind density there still a little bit elevated at 6.5 protons per cubic centimeter. Next are GOES magnetometers, showing some big dips there as some major plasma reorientation happens in the Earth system. The GOES 16 and GOES 18 are geosynchronous orbits that are near equatorial in their orbital location. The N's and M's up in this top pane up here, those N's and M's stand for noon and midnight local time for the satellites. Don't forget to press the like button. If you haven't pressed the like button, make sure you do it now. Press the like button or the video cannot continue. This is a space weather dictatorship and you are required to press like. Otherwise, there will be problems. Problems with us getting as many likes as we ought to receive. So, yeah, check out our shorts if you haven't, by the way. If you've got low attention span pals who might be into space weather, show them our shorts. They're, shall we say, rather popular over the past few months. Seriously, though, thanks to our new YouTube subscribers, etc., congratulations on realizing the channel exists. We remain frankly surprised that you have found the channel. So many facts are very dangerous and very inconvenient. So, anyway, here's our top view ecliptic plane field plot, and there's a sector boundary crossing that's going to be here before tomorrow's daily space weather video. So, if we bring up the last image here, there you go. There's a sector boundary crossing just about to arrive, probably within the next about 6 hours. So, Earth is going to be in a North Pole-oriented magnetic field, certainly by tomorrow's daily space weather video. Here's our line of sight field plot. Here the solar B field depicted in blue, polar fields in green and red for north and south respectively, and the photosphere magnetism depicted in grayscale. So that's our line of sight field plot. Here's our line of sight ecliptic plane plot. We are seeing a little bit of waving around over there in the eastern limb once again. Looks like a little bit of magnetic indecision has happened in the past day or two. And let's move on to coronal holes. So coronal holes are super important as they trace the magnetic field reversal process that occurs during each solar sunspot cycle. At the moment, we've got South Pole-oriented coronal holes rotating to the west and North Pole coronal holes rotating in from the east. So that's the latest image. And before we continue on, let's show some imagery of, there's the SDO 304 plus 335 angstroms. And here's our coronal hole wavelength, 211 angstroms. So basically what's happening is these are south, These are north. Sector boundary crossing is imminent. And here's a little closer view of that very well-defined southern coronal hole. And by the way, folks, expect an uptick in coronal holes over the next 2 years to continue. We've had a shortage of coronal holes during this solar cycle, and that's called statistical forecasting. So that's what's going on. And let's move on to sunspots. So first, the sunspot number, it's still hovering around 100. So there's... Oh, I stand corrected. It's currently way down to, what is that, 70? About 75 sunspots. So, yeah, the sunspot number has dropped since yesterday. That sounds more logical. That sounds like what I was forecasting. And here come our flare probability and flare scoreboard. So some of those spots do have some magnetic complexity. It's not looking like a really great time to see large solar flares. Pretty magnetically simple sunspots. And let's take a look at SDO. Here we've included the 94 angstroms wavelength to highlight active regions and the SDO continuum to show the sunspot ombre. So that's the scenario. Here's just SDO continuum. That's what about 75 sunspots is going to look like. And before we do energetic particles and solar flares, let's talk about cosmic rays. We haven't done a cosmic ray update for a while, and we've got some interesting factors to show you here. So we are seeing what's called a Forbush decrease. That is when cosmic ray flux suddenly decreases, typically because of things like coronal mass ejections, also coronal hole high-speed streams. It is a rapid reduction in cosmic ray flux associated with the magnetic fields from the incoming solar plasma. So we are seeing one in effect right now. There's the Activity neutron monitor, and you can see there starting around midday on the 5th, a rapid decline in cosmic ray flux at Activity. Also at Barentsburg. So no real surprise there. It's what you would expect during geomagnetic storm conditions. And we've also got the Athens, Greece neutron monitor. There's the Forbush decrease at Athens, Greece. Now showing a significant decline in the past 30 days, just like Activity and Barentsburg. Also Mexico City. Whoops. Here's Mexico City. Also a significant decrease in the past 30 days, thanks to that Forbush minimum. The Forbush decrease. And last but not least, we'll show Oulu, Finland, and Antarctica. So there's the Oulu neutron monitor. Significantly down over the past 30 days, as you may have come to expect. Lowest levels of cosmic ray flux since 2004 across most monitors. And here's Antarctica. So there's DOMB, down over the past 30 days, and there's DOMC, also down over the past 30 days. So that's your cosmic ray report. We show them at least once a week on the channel. And again, if you want to read about Forbush decreases, there's an article on Wiki about it. Forbush decreases, a sudden decrease in cosmic ray flux as a result of incoming solar plasma. So that's what's going on with cosmic rays. Let's take a look at energetic particles. These are measured by the GOES 16 and GOES... Oh, just the GOES 16. Yeah, just the GOES 16. All right, so there's the proton flux. No spikes in the proton flux. No solar energetic particle events. We have baseline readings on the GOES proton flux. As far as the X-ray flux, the past 24-hour average is over a C class. It's something like a C1.5, I suspect, by looking at that graph. And no major solar flares over the past 24 hours. Let's take a look at them from SDO. There's SDO 94 plus 131 angstroms. Another 24-hour video from Solar Dynamics Observatory. And it looks like we did have multiple regions producing C-class flares, the main ones being in the southeast. Well, some in the northwest as well. Anyway, you be the judge. Again, no major flares have happened in the past 24 hours, so there you go. There are the past 24 hours. And let's move on to a star chart. So there's, if I press now, there's what's going on overhead over Lehigh Valley. That's skyandtelescope.org. The two largest planets in the solar system are up there, visible over Lehigh Valley, Pennsylvania at the moment, Saturn and Jupiter, following sunset here in eastern Pennsylvania. Next, your solar system forecast. So there's where things are today. We'll advance this 1 week. And it looks like we're about 8 days from a new moon. So that's where things will be. On the 13th of November, we will have a tiny sliver of a moon. Yep, it looks like new moon is on the 14th. So moving right along to our astronomy photo of the day. This one is from the French Alps. So a great view there of the Milky Way galaxy. The Italian Alps, as well as some red aurora over there on the right side of the image. apod.nasa.gov if you want to check out yourself. And the town you're seeing there is Comelico Superiore in the Italian Alps. Pretty sweet. And let's move on to CMEs. So we have had some. And let me go back to yesterday. There are yesterday's coronal mass ejections, since these videos do include a couple hours of the previous day because of when they now take place in an evening time slot. So there are yesterday's CMEs. That is 100 frames. And here are an additional, let's see, 88 more frames from today. So you're going to see one significant CME out of the southwest, and then possibly a secondary event. Now, that secondary event might have an earthly directed component. If so, that one could be expected to arrive sometime around November 10th. So possibly late in the day on November 9th, more likely early in the day on November 10th. I think there is a secondary event there. We're going to show it to you here in a minute. First, we'll show the C3 as well as the C2. That was just the C2. And here's a little closer view of that. So again, it looks like there were two separate events happening here. One was out of the southwest, and the other one was more center disk. So there you go, early this morning, that's CME out of the southwest. And then there's additional ejecta trailing it that the first CME might have been obscuring. So that can create some problems with contrast. And so closer to midday, there was a secondary event there. So we'll get to it here in a minute. First, we're going to show stereo A. Which is located right about there. Getting a little more and more angle on the Earth as it speeds away from the Earth. Now ahead of planet Earth, orbitally stereo A, folks. Here are its coronagraphs. Coronagraph on the left, difference imagery on the right. Let's see if that shows us anything else. So there's that CME from early this morning. Let's bring that back. And there is a difference imagery as well. And we'll bring that back. So now you can see some ejecta coming out of the east, but I think there might be a stealthy CME mixed in there that could have earthly directed components. So here's what I'm talking about. Here are our custom coronagraphs. It's a 24-hour video, SDO 193 plus C2NC3 from LASCO, the SOHO spacecraft. And if that's not a close enough view, we'll zoom in one step closer here. The secondary event was right around the center of the disk. So it might be more obvious when we move in one more step and add 304 angstroms, so let's do that next. So you can see some brightening happening in here. I'm not so sure. Yeah, that could be a second CME there. So anyway, don't be surprised to see another minor impact. Let's see, late in the day on the 9th or early in the day on the 10th. So space weather here is going to continue as a coronal hole high-speed stream is right behind these currently impacting CME impacts, and then another CME impact, a small minor one, which was kind of stealthy to begin with behind that. So enhanced solar wind to continue here for several days yet. Here's just 304 plus 193 angstroms. And you'll see this CME down here, and then right after it, you see motions up here. Also, we did note that one of the filaments did seem to partially eject, which you'll be able to see on the hydrogen alpha imagery, which we're going to show you next. So, again, folks, don't forget to press the like button if you enjoy the content. Yes. Press like or else. So here you can see this activity right in here. Part of that filament does look like it ejects. And that is about the location of where that second CME looked like it was coming from. So I do suspect there is a second CME on the way. That's my story, and I'm sticking to it. By the way, if you want to name filaments after living people, join us over on Twitter and follow the hashtag #NameThatFilament. We'll also show the grayscale hydrogen alpha imagery because it shows the edge of the solar disk there showing prominences, and there are some in the east and some setting in the west. Before we get to bonus features, here are the past few hours from the GOES 16 SUVi. With its wider field of view, it's great at showing CMEs as they make their way out of the sun's atmosphere, known as the corona. And let's go on to bonus features. Yes, bonus features. You got to have it. Satellite charging hazards. We do have some surface charging there. Areas there over Southeast Asia and Western Pacific, the Philippines. Seeing areas there overhead where satellites are having low-energy electrons build up on the outside of them. Those can cause some communications errors. So if you are using satellites in those areas, you might see some slight communications breakdowns. West Pacific, East India, places like Korea, Indonesia, Malaysia, etc. Surface charging there. GOES electron flux has cratered, but now it's coming back up off the floor. So we saw quite low levels. Now they're getting back to more nominal levels. That's the GOES electron flux for the past 3 days. Here's the 1-year graph to contextualize it. You can see that rapid decrease in the electron flux. That is a common erroneous feature that we see during geomagnetic storms. Next, the forecast model from NOAA. And it looks like NOAA's going to underestimate the next forecast also. So I would anticipate the next data point being somewhere around here. The green boxes are the forecast and the yellow diamonds are the observation. Next, we'll show the layer where it's measured, the F layer of the ionosphere. It's one slice. The slice at about 300 kilometers of altitude. So here is the F layer in megahertz. And we're seeing lots and lots of low frequency and very low amounts of high frequency in the F layer. So that is an ongoing geomagnetic storm. That's what you could expect it to look like. also show the anomalygram, and you're going to see a lot of red, a lot of low-frequency anomaly there. The ionosphere is quite excited here. Excited about space weather, just like so many viewers going out there and getting images of the aurora, perhaps for the first time. So lots of low-frequency anomalies here. This depicts anomaly in megahertz from the 30-day median. Here's the latest image. That's 2300 universal time for the ionogram, and there's the anomalygram for 1 hour until 0 dark midnight. Next, the whole atmosphere model, the global ionosphere nowcast, showing total electron content on the left, maximum usable radio frequency on the right. Giving you one snapshot for a lot of data all at once as we try to condense a lot of information into a little video. Next, total electron content by itself. It's depicting free electrons in about this type of range, about 12,500 miles of free electrons. Here's the global view, which still looks erroneous, by the way. It's showing an incredibly low number of electrons, and that just does not look valid. But the anomaly over North America does look legit. So here's the anomaly in total electron content over North America. That's anomaly from the 10-day average. And some sporadic, rapid shifts there in the electron content as Earth's magnetosphere attempts to reach static equilibrium. We'll close out space weather with the latest intensitygram and latest colorized magnetogram. There you go. Again, those sunspots are not that magnetically complex. That one's beta-gamma class. That one is also beta-gamma class. So not an optimal situation if you're hoping to see solar flares. Maybe some new active regions here rising around the east. I do see some active regions there. So perhaps some new sunspots to rise over there. But for the moment, pretty weak levels of solar activity have returned. And let's get to meteorology. So the first thing we're going to look at is nullschool.net, as we do on the daily. And did you know that nullschool.net actually shows auroral forecasts? Yeah, if you click on the space right there, space, you've got air, ocean, chemical, particulate, and biosphere. If you click space, it's going to show you the auroral forecast. So that's what's going on in terms of the aurora here at the moment. Kind of weak. Don't be surprised to see it kick up once again. So be ready if you're going to go out and try to capture yourself some auroral imagery. Make sure you have your camera set up correctly, and I won't get into that. It's a little complex, but here we go. These are the meteorological data of your lives. These are the surface winds of the east, jet streams of the east, jet streams of the central world, surface winds of the central world, surface winds of the west. And there are your jet streams, doubled up jet streams over the U.S. at the moment. And here is the view of clouds and fog. So that's clouds and fog for the Americas. Rapid cloud nucleation happening there over Brazil, for example. Check it out. Some spring action happening there. That's shortwave radiation from the NASA GOES Interactive Weather Satellite Suite. And here's just a view of clouds and fog over the eastern U.S. The shortwave radiation map should give you some idea of where the aurora are likely to be seen. Could they be seen as far south as Tennessee? You never know. And check out precipitation type, folks. We've got quite a bit of snow falling in the northern hemisphere there. So I like viewing precipitation type on windy.com. It's one of my favorite layers that I like to use. Mostly rain here at the moment. But some of the white stuff is making its way to the ground. Next to your weather.gov map, if your location is lit, head to weather.gov and click your location. There are too many waterways and counties for us to cover. But at the very least, we showed you the key. The heck? We showed you the key. Weather.gov, and here come some forecasts. So first we've got the GFS pressure and precipitation forecast. There you go, 72-hour GFS. And it looks like some ice is coming to New York and New England in about 3 days. Dag. Next, the jet stream forecast based on the same GFS 72-hour model. And last but not least, the temperature anomaly forecast. We've got a possible record-breaking high temperature coming tomorrow to eastern Pennsylvania. So quite a warm spell there will make its way across Missouri, Illinois, Indiana, Ohio, etc. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Here is the lightning mapper. Look at that extreme lightning kicking up in northern South America. Pretty exciting stuff. And here's a real-time lightning map. We noted there were quite a few lightning strikes in the Atlantic Ocean. That's lightningmaps.org if you're wondering. Yes, you can use it to forecast thunder. Check it out, some Idaho lightning happening there. And let's move on to close this thing out with U.S. Doppler radar. There's the full 50 state. Here's a lower 48. That's where the precipitation's happening. Here is, once again, clouds and fog. And there is the water vapor map. That should clear things up if your Doppler is unclear. Here's your recap. That's vertical motion in the air column from ground-based Doppler radar systems. Space-based shortwave radiation at 3.9 micrometers infrared. Clouds and fog, they emit radiation, infrared radiation. And here is a different band of the infrared spectrum, 6.19 micrometers infrared radiation, depicting the water vapor, as in all of it. Anyway, hopefully you've been excited by space weather, as in all of it. And thanks for tuning in to the Smash News Network. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. And speaking of back, I'm going back to the bunker again. Lots and lots of stupid stuff. Encouragement to climbing.